Okay, number 4 asks, which of the following is the strongest base? That means that we're looking at the ability of these compounds to accept a proton. In all of these cases, we're looking at some lone pairs on oxygen and nitrogen. So this oxygen has 2 lone pairs, this oxygen has 2 lone pairs, this nitrogen has 1 lone pair, and this nitrogen has 1 lone pair. In each case, an acid-base reaction is going to occur whereby either oxygen or nitrogen is accepting a proton with a lone pair. And so which is able to do it best? Now, what we have to understand is that these lone pairs are not all equally available for acid-base reactions. Some of them are tied up in resonance. So for example, over here on this phenol, we've got a lone pair that can get pushed down here, and then all of this pi electron density can be delocalized. We have a lot of different resonance structures involved there. Because that lone pair is tied up in resonance with the rest of the molecule, it is less available for accepting a proton, and therefore phenol will not be as good of a base as cyclohexanol. Likewise, we can say the same thing for aniline. This lone pair is tied up in resonance with the rest of this molecule. We can push that lone pair around. That lone pair is delocalized. If that lone pair is delocalized, that electron density is spread out around the molecule. It is less available for accepting protons. That is not the case over here. Over here, that lone pair is completely localized on the nitrogen atom. So that is going to be much better available for acid-base reactions and accepting a proton. So we know that it's not going to be either of these. These are the ones where it's bad because of resonance. And so now all we're doing is we're comparing an oxygen atom and a nitrogen atom. And as it turns out, a nitrogen atom is a better base than an oxygen atom. It's better at accommodating another proton because N+, what results, is more stable than O+, because of the higher electropositivity of nitrogen. Nitrogen is to the left of oxygen on the periodic table. It can better accommodate a positive charge. So we're going to go with D there. D is going to be the strongest base.